Okay, now it's time to talk about Newton's second law. So Newton's second law basically states that if you apply a force to an object, an unbalanced force, that object's going to accelerate in the direction of the force. So, I don't know how many of you have seen the game Mega Man. In Mega Man likes to slide along the ground. And you notice when he's sliding, he stays at a constant velocity. But if we apply a force of friction to Mega Man, I want to know what's going to happen. So in this next clip, I went out dressed up like Mega Man, and I slid around. Now we're going to see what happens. The data you need to answer the question is in the description below, along with the question. Enjoy. Good luck. So all that playing around in the snow got me craving a rip down a hill on my snowboard. So your next task is going to be to calculate my acceleration as I go down a hill. Now to do this, there's a couple things you need to know. Gravity is still the thing that's causing me to accelerate down that hill. But gravity is acting straight down. This hill is sloped at an angle. So there's a component of gravity causing my motion in that direction that we call FG parallel. Now to find this, we can do trig and find the component of this right angled triangle where FG is our hypotenuse. So using trigonometry, we can find that FG parallel is going to be equal to FG, which is our hypotenuse, multiplied by sine theta, which is the angle of elevation of the hill, and it's the same angle you'll find in this triangle right here. Now, another thing you need to know is the force of friction. To find the force of friction, we need to know our normal force acting on me as I'm on the surface of the hill. So again, it's not going to be the full component of gravity, it's going to be the component that is perpendicular to the surface. So to find FG perpendicular, we need to take FG and multiply it by the cosine of this theta here. So we get our adjacent from our hypotenuse by using the cosine. Once we've done that, we take a look at our net force equation, and from Newton's laws, we know that that net force is going to be equal to ma. So the only forces acting on me that aren't cancelled out are going to be my FG parallel and my force of friction. So if I add those up, I'll get some total force and divide by mass, and I can find my acceleration. Good luck. All the details, like the angle of elevation of the hill I was on, are in the video, and in the description. Have fun, I'll see you. To measure the angle of inclination, we can use a clinometer. So there it is right there. Finally, we're going to talk about Newton's third law. So for every action, there's going to be an equal and opposite reaction. So I can't touch this wall without it touching me. And I can't push harder on the wall than it can push on me. So an interesting application of this is the idea that if you have a fan providing thrust on a cart and you try and power your own sail, so blow this air into your sail and try and get your car to move forward. Now, Newton's third law says for every action there has to be equal opposite reaction. So whatever force you're pushing that fan with there should also be a reaction force pushing back on the fan here, resulting in a net force of 0. So if you remember from before, whenever we have a net force of 0, our acceleration also is going to be 0. Therefore, if this card is sitting motionless, it will remain motionless. Now, they've tested this out, and I want you to watch the next video and see for yourself, and then you have a couple questions to answer in the description below.